So hello everybody, my name is Andreas Uphaus from Bielefeld, and there you find Lukas Novak directly connected from Brno. We'd like to welcome you to this webinar about implementation of blockchains and smart contracts. And in the first part, Lukas will show you some theoretical aspects about this implementation. In the second part, we want to do some hands-on with a little supply chain implemented in Hyperledger. But before starting, some notes. The slides you will see will be published later on the chat tab homepage. You may ask some questions within. Use the chat on the left side down, and we will answer your questions 15 minutes after this presentation has ended. And we will record this webinar, and hopefully you will enjoy it. So let's start. Lukas, it's your turn.
Thank you, Andreas. Hello, everybody. I'm very happy that you find time to join our webinar about implementation of blockchain and smart contracts. My name is Lukas. I'm working at Brno University of Technology. I'm mainly focusing on emerging technologies and information systems. And one of the emerging technologies is definitely blockchain, which we'll be talking to today. So blockchain is only just one tool when you're considering templating digital transformation. There are many of tools, such as Internet of Things, robotic process automation, cloud technology, artificial intelligence, and definitely blockchain. The question is, what is blockchain? So you can imagine this as something like a data storage, but really special data storage. It is decentralized and called ledger. So it's called decentralized ledger of all transaction in network. And the goal is to increase security, reduce cost, decrease transaction time, and also increase transparency. Also, the main goal is eliminate the need of trusted third party. So this is what blockchain is, really high level. And let's take a look on one part of the blockchain, because one part of the blockchain is a smart contract. And let's start with the introduction, and I will talk also about the benefits. So first of all, what are smart contracts? So smart contracts are software-driven, automated rule agreements that require limited or non-human interaction. It allows reduced dependency on third-party validation and increase autonomy. The question also is how the smart contract works and how you can implement it. So the implementation is pretty simple. The smart contracts are written as a code in blockchain, and then once this is set, the contract is executed itself or with some limited or human interaction, and then when the conditions are met. So when the conditions are met, then the contract is executed. Okay, so let's talk about the main benefit of smart contracts. So first of all, it's autonomous. It's something I mentioned before. So it's a self-governing and self-executing. And also smart contracts react automatically to external triggers. Then the next thing is trust built in. So smart contracts can only change data state if there is network consensus for that change. This is something which is built in a blockchain itself. Then let's talk about the replication backup. So every node on a node, we call it node. It's a like a participant in a blockchain network. So every node of the network has a replicated copy of the contract. Contracts cannot be deleted. The other benefits are definitely the speed of the execution. So the smart contracts significantly eliminate the manual processes because, as I mentioned before, it requires almost non-human interaction. So processing times are significantly reduced. And consequently, we are saving the cost because there is almost no human interaction. So we can save some cost. So the smart contract perform the function of the middleman. Therefore, we are saving time and cost. And also, the last but not least, error limitation benefit. So manual tasks can be taken care of by smart contracts, and that's why we are eliminating the human error, because it requires limited or none of human interaction. So that's it. So right now, you know something about the blockchain, and you have a high level information about the smart contracts. And now we can focus on, let's say, implementation of blockchain and the criteria which can help an organization to determine if the blockchain and smart contract solution is appropriate. So we put together a couple of criteria, and first of all, there is the first thing is about multiple parties which sharing data. So if there is a multiple participants which sharing data of let's say common information, then the blockchain is definitely appropriate solution. Then the next thing is about multiple parties updates data. So if multiple participants take actions that need to be recorded and change the data, then also the company could consider the blockchain solution. Then I would like to focus on requirements for verification. So if participants need to trust that the actions that are recorded are valid, then also the blockchain is a good, really good solution. Also, we can talk about the time-sensitive information. So, if the company would like to reduce delays, and it causes some benefit in a business, then definitely also the blockchain is good solution for the company. And last thing is about transaction interact. So transactions created by different participants depend on each other. If there is something which you know from your company, then definitely also the blockchain and smart contract is suitable for the company. So let's move to the next slide, where you can see that the blockchain and smart contracts could help reduce some limitation. So let's say the modern digitalization can have many benefits, like reduce manual efforts, improve collaboration, or increase efficiency. But as well, there are many limitations, like manual effort still exists in reconciling updates to centralized source, or transactions still need to be approved by a trusted third party, or this is about the time and cost. Latency still exists due to party synchronization. And those are things that we can eliminate or partially eliminate by implementing blockchain, because updates made will instantly reconcile to single source of truth held by all parties. This is like this is what blockchain is about. Then consensus algorithm enable automatic transaction approvals, and this is about the efficiency. Combination of distributed data and rules further reduce errors and lag time, because the processes could be run smoothly and much effectively on the blockchain. Okay, and then let's move to the next slide. I have put together a list of proof of concept and examples where you can see the blockchain solution. So let's start with the first one. It's about the trade finance pilot. So it's about the collaboration with large software company and bank, where both subjects build a standby letter of credit proof of concept, and they are taking multi-day 15+ step process to only 5 steps within near real-time data availability. Then the other examples are mainly about the supply chain. As you can see on the second example, where was designed a solution that leverage a cloud-based predictive analysis and share workflow to improve cash flow and data integrity across the order to cash process. Or there is another supply chain pilot. It was done for a pharmaceutical company, where the company would like to prevent fraud by implementing blockchain over chain of custody of prescription drugs. Overall, as you can see, the blockchain solutions are implemented in processes where multiple parties sharing data and require verification to prevent fraud. And yeah, that's almost everything from my side. I would like to thank you for your attention, and I will pass ball to Andreas. I will stop the presentation and ask Andreas to continue. Floor is yours, Andreas.
Perfect. Just a minute.
If you have any questions, you can definitely ask me on the chat, and we will answer your question once we get to the finish of the presentation.
So thanks, Lukas. I want to start to tell you something about the realization of a little supply chain project under Hyperledger. So let's try to get hands-on. It was, in my mind, a little bit a self-experiment, because I said, well, I do not really know how to implement it exactly, and I want to learn how the feeling is. And what do I have to know? How complex is it? And so on. And I will go through a lot of slides, but only to give a short overview. And you must not understand everything in detail. So let's start. Our agenda is, at first, we want to look for what supply chain projects under blockchain are. Second step is the short introduction into Hyperledger. And the third one, the simple example implementation, possibly as a live demo, we have to look for. Well, what is a supply chain? As a first point, I don't want to give a detailed scientific definition, but a supply chain is simply you've got some suppliers or a supplier network which delivers something to a producer who sells something to customers and retailers. And for each step of this gray arrows, you need a carrier, typically a bank or an insurance or a government agency to prove something. What we want to do is we want to look only at this small part, a supplier, producer, and a carrier. And this could be modeled as a delivery process, as a flow chart. And even in this flow chart, we want to have only a look at this special part where suppliers send some parts to a producer using a carrier, and where the producer has goods incoming department which tests and makes quality checks. Everything could be implemented here with blockchain contracts, but we only want to have a look at that short part. If we want to implement supply chain project, especially under blockchain, maybe the following implementation guideline could be helpful. At first, you should ask yourself, what is your target? What do you want to implement? Then you have to identify participants internally and externally with whom you agree that you want to do a blockchain as a new project. And then you should think of a kind of a project declaration. This means look at costs, at time, at resources, and define yourself if you find that there is a return on investment or not. If so, the fourth step is to define a use case model, which typically consists of defining some assets like contract, shipments, and so on, defining the participants exactly, looking for access control, because not every participant has to have the same viewing rights on the contracts and on the blockchain itself. And then you should define some transactions like smart contracts and so on. So at the fifth step, you should look for some legal aspects and then choose a platform in a sixth step and some infrastructure. You have to define some technical and system requirements, especially on IT security, to realize a project. Then you have to decide if you're skillful enough to do this project, or if you need some technical help, or maybe some technical orientated new employees. Eighth step is to implement the blockchain, which costs a lot of time. Then you should test it, and in a last step, administer, run, and update it, which costs a lot of time again. So this is a simple use case, a letter of credit example shown in a book, and you see only for this simple part of a supply chain that there are a lot of participants and that it is a very complex process. But let's define a use case for ourselves. Let's say we want to implement an Internet of Things-based supply chain network. We've got a supplier here who produces some parts like gears, shafts, and E-plates and plates for an E-motor. That is a shaft, for example, and send this to a producer via a carrier. So all three participants must have a view on the blockchain and on the contracts. The smart contract could be, in this example, defined as a delivery of something, let's say shafts, which have some quality aspects. Our shaft should have a diameter of 100 millimeters. The price per shaft should be $20, and we would order 5,000 pieces, so the contract volume is 100,000 euros. But we put some quality aspects in, and that is, if the diameter is lower than 98 millimeters, there will be a price reduction of €1 per part for all parts. And if it's higher, than the maximum size of 102 millimeters, the price should be reduced of 50 cents per part, and that is a penalty for all parts. A second condition is implemented, and that is that we're doing just-in-time production, and if supplyment comes too late, this will cause a payment of 0. Surely this is not absolutely real, but it illustrates how this might work. Our shipment has the number ship 001. In step 6 of our agenda, of our implementation guide, we should ask ourselves which platform we should use. Why should we use Hyperledger? Well, here is a little comparison. Hyperledger here in this last column, which is based on Go and Java. And well, we choose this right now, and we have to ask, what is Hyperledger at all? Hyperledger is a project which you find under this link here above with 250 members of large industries, founded in 2015. Hyperledger is a conglomerate of several frameworks and tools, and we want to look today only for building up such a blockchain on the Hyperledger Composer, which is based on the Fabric framework. So what do we have to know in this context? We have to know that blockchain is in some way a kind of database, which is implemented here as Fabric. The Composer is something like a programming language you need to build up a software itself, and you need a front end or user screen. That is Iroha in this context, and some others. But we only want to have a look at this composer with the modeling language CTO and some other aspects. So the blockchain itself is not directly visible, but if you use somewhat software, you only have a view on the front end and not on the database itself. So this is the universe of IBM blockchain platform. IBM strongly supports Hyperledger, and we want to look at the development part, Hyperledger Composer, and here at the web playground, you see that for govern and operate a blockchain, some other things are necessary. Well, you have to know and to learn some things or have an idea of how to deal with if you want to implement Hyperledger. You should have a Google Chrome browser. That's quite simple. You will get rid with some concepts like Docker, Git, or Linux, but not in that detail. There are a lot of introductions about Hyperledger, but not all of them are really useful. The best one is the introduction shown here under this link by IBM and maybe by Hyperledger. Nearly all others have some problems, let me say. One thing in step 8 you should do is you should design a network. If you want to do so, let's say for a letter of credit, this could be somewhat challenging, like you see here, and it's described in a blockchain book with Hyperledger by Gower and Co. And they said that they had some challenges in implementing, but I think it will work, and that is what we will see. So at first you should start Hyperledger in some thing, and you should in some way, and you should learn from some examples. Above you see the Hyperledger link. You could use it with a simple browser and start your first project. IBM has a lot of use cases shown here, and choose one of them to try to build up your first blockchain. I used perishable network and changed it to our use case. That is what we see on the next slides. In step 8, we have to look for that Hyperledger has to deal with some key concepts. Like we said, we need some assets. In our context, these are contracts about gears, shafts, and plates, and shipments from the supplier to the producer. We've got some participants like supplier, producer, carrier. We need some access control because not everybody has the same rights, the same viewing rights on the blockchain. we need to define some transactions here. That means a transaction is, for example, a producer receives a good, or an IoT laser measurement checks some incoming parts. And the result of a transaction is always an event. So now we have to know that all these things, assets, transactions, access control, queries, and so on, are stored in files in Hyperledger, and they're just stored in a BNA network. What we want to do right now, or what I want to try, is to do a short live presentation. Therefore, I change to my network. You see here, okay, hello, let's blockchain. That's what we want to do right now. So we deploy our first business network here in the Hyperledger Composer Playground, and you see here down here all these examples. But we use an example I have prepared for today, that is this one, and deploy it. Hope it will work. Just a minute. So here we've got our network card, our business network card, and we connect with our supply chain network. You see here the files we have described. A README file first, where our project is explained with the participants, for example, and the assets and the transactions we want to do. Transactions are that we want to set up our project, we want to set up this IoT measurement and shipment receive. Then we will look in the model file. You see here a lot of coding, but this in CTO, but this is not very complicated. That is my experience. Here, for example, you see how a product is defined. Yeah, we have 3 products: gears, shafts, and plates, for example. Then we got a little further and find here an asset contract. That is our smart contract. It's defined as available for supplier, carrier, and producer, with some parameters like date, unit price, and so on. So that was a second thing we have defined. And the last one is here, our participants. And we see that we define here a supplier, for example, with its email. So that is what is in the model file. Now we go to the script file and look for what happens over there. These are transactions, for example, a payout transaction. This transaction calculates how much the payout will be from the producer to the supplier, including all these penalty payments. So the first step in our contract, in our smart contract, is here: if the shipment is too late, so if shipment date is larger than arrival date in the contract, the payout is 0. We pay nothing because we have just-in-time production. Yes, the second clause is here, that if the size is larger than the maximum size here, which is measured by our IoT laser measurement, then if this is larger than the maximum size in the contract, there is a penalty implemented and shown on the console. And the last one we see here is that our result is put it on the screen, how much is to pay. So that is how we define a simple project. Now we have to test it. And that is what we want to do here. Sorry. At first, we have to submit a transaction. This means we have to start our model. And while we've seen for the carrier nothing before, now the carrier, the producer, the supplier is defined. And if we look in, we see here that yes, the email address producer@email.com. Also, we have implemented a contract here. You see here the contract is specified at a unit price of 20 euros, minimum and maximum size for the quality control and the penalty payments. And at least we've got our shipment 001 with 5,000 parts and the contract number con 001. Now we have to submit some measurements of our IoT laser measure instrument. And let's say the first one is still okay, 100 millimeters for shipment 001. We submit it, so it has worked. We do another measurement, let's say, again at the same time, realize size reading. Now the measure is too low, only 90 millimeters for the diameter, and we implement it here again on the same contract. Okay, so we submit it. And a last one, a last IoT measure is done, and we say the last one is, let's say 110 millimeters. That's much too much, and therefore we have to implement some penalties. Okay, I submit it, and as a last thing, you see here the contract at all with 190 and 110 as measurements. And in the next step, we have to submit as a transaction that we got the shipment receiving of our shipment, that is ship 001. Okay, I submit it, and it's now implemented. We see here the transaction code of the blockchain, but nothing more. We could change this when we look at the Java editor, and we see here that these are our inputs from the IoT measures, and we see the lowest size was 90, the highest size is 110, and we have to pay penalties, and the payout at all is 40,000 euros, and that is what I want to show you as a last slide in my presentation. That is what you can see here. Yeah, for the low size here, we have to pay a penalty of 8 euro per part. For the high size, only of 4 euros per part. Both together are 12 euros for each part penalty. So we have to pay 8 euros per part multiplied by 5,000 parts means that we have to pay as a producer to our supplier, instead of $100,000, only 40,000 euros. Surely this is a very extreme example, but it shows how blockchains on Hyperledger work. What is my conclusion? Well, my conclusion is simply that supply chain projects are complex. You should start possibly very simple. Hyperledger is in a flux. There is a lot of open space, and it's really technically driven. But don't fear to try to get an impression. You should start learning and understanding by using examples. Create your own example as a second step. Then you get a good idea if you need some technical support, and then realize your supply chain project. So that was it from my point of view. Thank you very much for listening. Okay, everybody. Then we should get back. Hope you have enjoyed everything. Then we should get back to the questions in our Q&A session, which we try to answer. The first question is, are smart contracts real legal contracts? And how could we link them to law world? I would say they have some legal impacts, because you have to agree that you will use smart contracts in a very safe way. If something went wrong in a network, in an order process or in a delivery process, then you may get in trouble if you have not agreed in a correct way to a secured blockchain. So I think it has some legal aspects, but while the implementation is not done so far in many cases, I think there are a lot of questions on the legal side too. A colleague of us may answer this. What do you think, Lukas?
I would add probably that the smart contracts will not replace the paper contracts, definitely. Because in the paper contracts, you will set, let's say, the fees, penalties, and everything, and you have to set there also you will use the blockchain to conduct the rules and process the contracts. So this is the difference, but there will be still the paper contracts.
Yes, and in these paper contracts, you should mention and agree on these automatical procedures. Exactly. So it has there exists some requirements which are of legal interest, and therefore you should check it deeply before you get into a mass process and make some mistakes and have to pay penalties in a very, very huge amount, like let me say Volkswagen or so. Second question, I think. Stefan Landwehr asks, furthermore, smart contracts shall be triggered by manual input or by things from internet. Who guarantees input quality? Well, like I've showed just in my little example, this contract was triggered by the by two things. One thing was this IoT measurement, which is just working automatically. Surely the supplier could ask, is your laser measurement at the producer, is it correct? Is it working or not? Maybe there have to be implemented in real world some let me say, quality procedures. This means that there will be a norm for these measurements, or that you will just check as a supplier in, let me say, every week or every month or once a year if this measurement works in the right quality. So it's a good question, and well, you have to be secure in some way. I think they will get up, or they will raise up some norms how to deal with this later on. Yeah, the other one in this context was the incoming shipment. So you've seen that the smart contract is really, so the IoT things are, let me say, some data you used to execute and to calculate in the end what the penalty or the price will be. But the original trigger was the incoming shipment. That is just still a thing you have already in companies at all, that there is somebody who says, okay, the good is incoming, we have received it, and we have to start. Otherwise, you will get on a mistake, and surely this will there will be some deeper look if this happens more often. But typically, this will work in this process I've showed. On the other hand, you've got the problem that if you got data from the internet, surely this is a thing, let me say, where you have to take care of. Let's talk about share data from exchanges or so. Let's say you will get some data, some prices from the internet to trigger transaction of some shares. then it is strongly recommended to use some data you could rely in. Data you could rely in are typically provided by Thomson Reuters or by Bloomberg. So that's even a question of quality of data. Lucas, what do you think?
Yes. So from my perspective, if there is a question about the how it would be triggered, so if there will be manual input or by things from internet, like Internet of Things, so I think that there could be both. So as you mentioned, Andreas, before, there could be like only automated trigger, or there could be like a manual trigger, or combination of those. So there could be like some one trigger based on the, let's say, quality of the goods, and also there could be a second trigger based on the manual check that everything is correct. So there could be a combination of those, or only manual or only automated trigger.
Okay, next question is from Dennis Titten. Could you provide the source code and files of your Hyperledger example afterwards to get even more detailed look? Yes, I can. It is maybe a little change of this perishable good example of IBM directly, where we can see the original code, but I will provide the files of the model and of the transactions for you together with my presentation. There will be no problem. Next question is from Friedrich Dörmann. Did this example run in the cloud? If so, is there a way to develop a network use case in Composer and then easily deploy it to your own local devices, Hyperledger peers? Yes, it is, surely. But that goes a little bit deeper into the story. So you have to install a lot of things before. You have, well, maybe you have seen that I have used an Ubuntu operating system. In this context, I have run it in the cloud. That is correct. What I did is this BNA file where everything is gathered. This means transactions, participants, access rights, and so on. That is a thing I have already stored locally, but you can run all these things locally. Therefore, you have to install Hyperledger and some other things like Go and so on. So the language Hyperledger is implemented in on your computer. That is a little bit more tricky, but it works, surely. And you can then, in the next step, produce some peers on your own, and that will work on your computer. And surely it is possible to use Hyperledger Composer even to compose code you use later on in a business network, which is integrating a lot of companies. Hyperledger Composer Playground is only a tool to produce codes in these files, and these codes can be used in each network. But I tell you, it's a little bit tricky. Okay. So I think next question is coming up. I see some typings. We wait a little for this. Okay. Well, what we've seen overall is that I thought that it would be very easy to have a workbench in Hyperledger and some pictures you use to form your model and make it very easy. That is not the case right now. It's just somewhat technical, but I think while companies like SAP and IBM are interested in that technology, it will be developed on, and I think in 2 or 3 years there will be, let me say, a user front end for developing blockchains in a more easy way. On the other hand, I must state, well, if you compare it with running an SAP system, you see SAP is not implemented just in 20 seconds. You need large infrastructure, you need very skillful people, up to 100 for a large company, and I think you need not that much manpower here for a large blockchain project, but it's quite a lot. So next question from Mr. Woost: do you expect that the blockchain technology will also be used in education, for instance, for ETC transfer? Well, I hope so. Let me say, there, as far as my colleague Rainer Lenz said, there are first projects which are doing things like that. So I would say that would be a good idea, a good use case. But on the other hand, I would say, well, in the public sector, it lasts sometimes very, very long till an implementation works, but it's a really good use case. So we should take an idea if we want to do this. What do you think, Lukas?
Yeah, so right now I'm working on or building a new subject in our university. It's called Emerging Technologies, and I will definitely speak there about the blockchain and smart contracts. And during the lectures, I would like to the students will be able to also implement some let's say really simple but blockchain solutions. So yes, we will be definitely working on transferring the blockchain into education.
Okay. So I see next question is coming up. Well, can you please explain ECTS transfer? ECTS is, let me say, short word of European credit system. Each module in the university has some credits, let's say 6, and you need a certain number of credits to get a degree, like a master or a bachelor degree. For example, 180 credits are necessary to get a bachelor degree at least. And you could transfer them surely between, for example, between universities, if you want to study here and there. And I think that is meant by ECTS transfer. I hope so, because Mr. Woost is just typing again. Hope I have answered the question correctly. Okay, thanks. But Mr. Woost is typing again. So maybe a short reply. I think next time we may try to do this not only as a chat, but the question and answers session could be done with pictures and videos. And so it will be easier to answer questions very quickly. Okay. Okay. Now I see no more question. Oh. So just one maybe coming up. I'll wait a little. We're just on the other hand okay. Many people say that the effort for building a blockchain is too high in comparison to proper whoops, to proper local databases with good interfaces. What's your argument against it? Lukas, it's a more technical question. I think it's for you.
Okay, so you know, it's about the trust, and I spoke about the criteria. If you was versed at the beginning of the presentation, I presented the criteria which can every company consider when before implementation of blockchain. And if there is like a multiple parties are sharing the data and it requires verification, then to prevent the fraud, then probably the blockchain is a bad solution. Because the data in blockchain are unchangeable, and this is the main difference. Because then you can trust all the transactions you have in the ledger. If you do not trust your supplier, and if you think that they will somehow change the data, then the blockchain is the best way how to prevent this. If you trust your supplier, then you can definitely run the application on a regular databases and interfaces. It's good. It's okay, and yeah, maybe you can save some money.
On the other hand, surely you need a lot of database space. If you talk about proper local databases, well, you're right. I think local implementation is only good for testing, to get a feeling of blockchains. If you will implement it really in reality, you should use server databases or even cloud databases. And I think companies like IBM have some interest to test it. The mass data test was one of the steps of testing, step 9 in our implementation guide, and it's surely necessary to do so before you, let me say, deploy a blockchain and it doesn't work. Okay, then the question is, do you send the presentation to the registered emails? We will put it on the chat tab homepage, and we will send a link to avoid too much data in our email clients. So last question for today, I would say, from Friedrich Dörmann. He's just typing in. Hopefully. Oh, does it come up? So you will get the presentation, yes, in this way or in the other. And if you've interest in, we could just talk about some things which are more of interest later on. Okay, I think it seems there is no more. Oh, last question. Okay. Wouldn't it be a bit against the blockchain principle to use blockchain in a cloud? Because the cloud is a centralized system, and therefore would have to trust the cloud provider. From my understanding, blockchain is a usage on a lot of separate devices. Yeah, that is absolutely correct. That is the idea behind it. But the question will be in the end, which are these separate devices? And while a lot of large companies are changing their spaces to cloud spaces, it might be not the same cloud space for everybody, but different cloud spaces for some companies. So I would say, surely, if you may implement, especially under security aspects, things on your servers, on your local devices, this will be a very fine thing. But I don't know if this will be the future. So you're absolutely right at that point. I would stress this, especially under aspects of IT security. But I think a lot of implementations are going that cloud direction, and it is in some way against this concept. If you have several clouds, it might work if you have several clouds. So it's up to you. If you need a high security, I think the network should be on your own devices, and then you have to look for what you will implement. A total supply chain, like I've shown, causes a lot of data, and I'm not really sure if this will fit on local or small devices. What do you think, Lukas?
I think that we are talking about different layers. So if you are talking about cloud and blockchain, then the cloud is something like it's more technical. It's about accessibility of the blockchain. But the blockchain is let's say the application in a cloud, because I imagine the cloud here is like a server hosted somewhere. It could be hosted by Microsoft or Amazon. So and it doesn't depend on the cloud provider, because the data in blockchain are unchangeable. So you can trust the information in the cloud, whether you have the cloud provider, let's say, everywhere. So the problem could be only if you have only one node, like a one computer, including your blockchain, only using one cloud provider. Yeah, it could be a problem, but the blockchain typology is a bit different. You should have more nodes, more, let's say, computers in your network. So then it could solve the problem regarding the accessibility.
Okay, so that was the Q&A session right now. Thank you very much to everybody. If there are some additional questions, you could find on the flyer our email addresses, and we surely will provide answers if you have additional questions. Otherwise, see you again somewhere later, maybe at a webinar or wheresoever. Have a good day and see you. Goodbye.
Thank you very much. Goodbye.